Hi there, welcome to JEE Advanced 2020 Solutions by Genesis. This is paper 1, section 2, question number 11. If you haven't gone through the paper, pause the video and read the question. A link to the question paper has been given in the description. You can download that, and I suggest as you go through the solution, keep that PDF open on the side. In the question, a semicircular metallic strip of thickness T and resistivity rho is shown, and the current is flowing through the metallic strip. Now they're saying that a transverse voltage delta V develops across the strip, and 4 options are given in which we have to find the current, and we have to see which edge of the surface is at higher potential and what is the relationship of the transverse voltage with the current. Now, to visualize what is happening, we first draw the lines of current density J vector, the semicircular arcs as shown in the figure. We will neglect any deviation from the semicircularity of the current density lines near the ends of the strip. So the question is, why does the transverse voltage develop? The current flows from the left to right, and therefore the electrons flow along semicircular path right to left, and this motion requires a centripetal force. The only way centripetal forces develop is if there is a transverse electric field E star as shown. This field will develop due to electrons being pushed to the outer edge as they move in semicircles. This immediately implies that the inner edge is at a higher potential than the outer one. This means C is correct. To find the current, let us take a strip of radius r and thickness dr. This strip also has a thickness T into the plane of paper, and therefore the area which is perpendicular to the current flow will be T dr, and therefore the resistance of the strip is dr is equal to rho length is pi r divided by T dr. And you can see all such elementary strips will be in parallel because the potential difference across them is V0. So the net resistance can be found by 1 by r is equal to integral of 1 by dr. And simplifying this, we get r is equal to pi rho by T ln r2 by r1. And therefore we get the current through the strip as I is equal to V0 by r. This implies that A is correct. Now, considering this thin strip once more, we can say that the current Di that is flowing through it will be V0 by dr, and we write the value of dr here, and we get an expression for Di. Also, Di can be written as N into charge of electron into area, here the area has been taken as T dr, into the drift speed. N is the volume concentration of electrons. This is quite a standard formula, NEAVD. Now, equating these two expressions for Di, we immediately get the value for the drift velocity. Now, this gives us a beautiful result that the drift speed is changing with distance. Personally, I feel that this is what J should have asked in one of the parts. Anyways, pushing forward, the electric field E star provides the required centripetal force for the electron, and we have E into E star is equal to mvd square by r. Substituting the value of Vd, we get this expression for E, and therefore the transverse potential difference will be the integral of this electric field from the distance r2 to r1. Now you can see that when you put the value of E star in this expression, the only thing that will get integrated is that 1 by r cube term. Otherwise, everything else will come out as constants. And therefore, we can straightaway say that this potential difference delta V is proportional to V0 square, and we have established previously that the current was directly proportional to V0, and therefore, without even evaluating it, we can say that delta V will be proportional to I square. Hence, D is also correct, and therefore, the correct options are A, C, and D. This is one of the most beautiful problems given by JEE in the past few years, and it double checks your basic concepts thoroughly. This question is a big no-no for students who have just mugged up a few formulae in current elect. Students who have studied the chapter well will enjoy the problem thoroughly, and it is quite doable for them. Keep watching out for more JEE Advanced 2020 solutions on the JEE Advanced 2020 playlist of Genesis YouTube channel. Till the next video, stay safe, stay healthy.